Okay, good afternoon class. So today we'll discuss significance of time, place, and person distribution in epidemiology. So you already know what is our objectives and our timeline. So let me find the result of class test. Okay, let me go here. We got, let me stop. Okay, we got 58 response, and we have two or three response from 3 students. You send twice. Okay, so we need to discard one because of lack of time. Let me go to result. Okay, so what is the total number of COVID-19 cases in Nepal? So what is your answer? Oh, what is the total number of COVID-19 cases in Nepal? So majority answered 9,561. So let me check which one is the right answer in this website. Okay, official website. Okay, so as the total number of cases till now 9,561. So let me see answer 9,561. Okay, so this is right answer. So majority right answer. Okay, so 53.4%, and you can see the variation of response. The first one is this, second one is 9,982, 29.3%, and rest 10,000, 8,500, 9,561, 9,700, 9,982. Okay, so this is your response. What is the total number of COVID-19 cases in Nepal? So this response reflects that being a medical student, you are not following the actual data. We have regular update in our government website, in Nepalese government website, so you can find all the data. Okay, so as a medical student, you need to be updated. Okay, you need to have up-to-date knowledge, because you need to counsel with your non-medical friends or community people or family. So you need to know the real data. Okay, even you can access this website and you can answer, no problem. This is open book test. And actually, what is the significance of this class test? What is the number of COVID-19 cases in Nepal means? It's a frequency. So it's a frequency or prevalence of COVID-19 cases in Nepal. Okay, so this is frequency. Now let me relate with our presentation. Okay, then I'll go to another question. So you can see this is COVID-19 epidemic or outbreak in Nepal. So currently we have COVID-19 outbreak, and you can find all the information in this Google Drive. It's freely available. You can see this is map of our country, and we are in the eastern part of Nepal. Our medical college lies at Morang district, which is one of this at the eastern corner of our country, Nepal. Okay, and let me go to next slide. It may be difficult, okay, for you to interpret, but I know you people are very smart nowadays. I hope you can interpret this figure. Okay, you can see we can correlate with COVID-19 outbreak. Okay, COVID-19. So initial period of epidemic, the first case seen at Wuhan, China. So it spread to within Wuhan. Okay, in maybe other countries. Okay, then you can see it crossed border. We can consider, actually it is not like that. It crossed border and it goes to other countries. Okay, so this symbol means immune person. This means susceptible person. Okay, this is immune. This is infected person who infects others, and infected person who fail to infect others. Actually, in the current context of COVID-19, we are in this stage. We are in this stage, means height of epidemic. It is spreading. So what will happen now? This black dots. What will happen? Infected person who fail to infect others at a certain point of time in this borderline. Okay, infected person Who fails to infect other, you can see it's closed here. It's already closed here. No more propagation. But these are the infected person who infects other. You can see the chain. Infects other, it crosses. So ultimately there will be a termination of epidemic after some month or some time. So this is the actual process how pandemic spreads in the globe. So it is from your textbook Park, okay, Preventive and Social Medicine, your book for community medicine, and you can see this is initial days. Okay, this means initial period of epidemic. This is height of epidemic. We are in this period of time at height of epidemic, and at last we may have termination of epidemic. We don't know, but it's already happened in some countries. In some countries still growing, in some countries already terminated. So you can see the typical pattern of COVID-19 outbreak. And what is the name of this type of epidemic? There is a specific name. So let me discuss in our next slide. Okay. Now, who is this? Anyone know him? He looks like scientist. Okay, who is he? Okay. Any guess? I have you unmuted. Okay, you can unmute yourself and you can answer. Any guess? Related to epidemiology. Okay, if not, mute yourself and try to listen me. Okay, while teaching epidemiology, while reading epidemiology, or while going through actual work of epidemiology, you should respect this guy. And he is none other than John M. Last. Okay, so John M. Last, John Murray Last, and at last you can see there is OC. What is OC? Please identify this. Okay, I'll ask in your Google Classroom. What is the OC? So he was born in September 22, 1926 and died last year, 2019, September 11. And he was a preeminent Canadian public health scholar. He's a prolific author, scientist and teacher whose reference texts are used by schools of public health, as well as community medicine and epidemiology practitioners throughout the world. So you can find all the information of John M. Last in this Wikipedia link and his own university link. Okay. So why disease or health problem occurs? You already studied the concept of epidemiological triad. Epidemiological triad means there are three things. One is agent, another one is host, another one is environment. If there is any disruption between agent, host, and environment, then disease spreads. Okay. There is environment, there is host, there is agent. If in terms of diarrheal disease or in terms of cholera, if we have poor drinking system or poor drainage and which contaminates our drinking water, okay, or our drinking pipe, okay, so it may infect infected with Vibrio cholerae, and it will ultimately spread to our host or human body due to our immunity. Okay, we may be asymptomatic due to our immunity, or we will resist that particular organism, or will suffer from cholera, and will suffer from rice to water stool, and we need to send for our stool test. Okay, hanging drug preparation. I think you already did in your microbiology class. So disruption and the relationship between agent, host, and environment leads to spread of any disease or health-related states or events. Okay, so why disease or health problems? So what is epidemiology then? Epidemiology, the gentleman describes epidemiology in his dictionary of epidemiology as the study. Okay, just before starting this class, I asked you for a class test. Actually, this is study to know your knowledge on current COVID-19. Okay, so we did study. Actually, I did study among you to know or to understand your level of knowledge. Okay, study of distribution and determinants of health related means this study of COVID-19 cases. Okay, especially study of knowledge of COVID-19 among first year students of Birat Medical College, and distribution of knowledge among yourself, and what are the factors that determines your knowledge in terms of your assessment in terms of COVID-19. Okay, I think it's more clear in terms of COVID-19. In terms of COVID-19, our first question is, what is the total number of cases? That means frequency. Actually, in this definition, you can see the study of distribution and determinants of health-related states or events in specified population. It should be specific, and the application of this study to the control of health problem. This is definition given by John M. Last. And here there are different terminology. Study, to study, okay, frequency, distribution, and determinant of COVID-19. So in context of COVID-19, actually frequency is not written here directly, but it is inherent to this definition. Okay, frequency means prevalence. So okay, in our first question of today's class test, so I asked you what are the total number of the COVID-19 cases in Nepal till date. Okay, so that is frequency. So frequency, okay, that is frequency of COVID-19. And distribution, the second one is distribution. In epidemiology, there are only three things. Frequency, I already told you, okay, from your class test, question number 1, this is just frequency. Second part is distribution, okay. Third part is determinant. So within distribution, we have three types, okay. Distribution according to time, place, and person. Distribution according to time, place, and person. And determinants means third part of epidemiology. The first part is frequency, as per question number 1. As per question number 2, 3, and 4, that is distribution, time, place, and person, TPP. And third part is determinants. Determinants means what are the factors that determine COVID-19? Why COVID-19 is more in developing in Italy rather than other countries? Why COVID-19 is more in province number 5 than province number 1? What are the factors responsible for high number of COVID-19 cases in our province 5? Okay. Or which determines, determinants means which determines the number of cases, spread of disease. So determinants means which determined health-related states, event, or any disease in specified population. I asked you in all questions in context of Nepal. So this is specified population. Sometimes we may have to specify within certain province or some district or Buriganga community itself. How many cases? I think Buriganga community we have only 4 or 5 cases. Okay, so specified population. Okay, actually people think that to identify frequency or prevalence, distribution, and determinant of any health related state or event in a specified population is epidemiology. It is not like that. It is only 50% of epidemiology. The remaining 50% means now you need to develop such strategy or application, okay, based on this research, this study, to control of health problems. So from your question number 1 of your class test, I found only 53% students are on right track. That means, so what are my intervention? What is the application of this test? Okay, question number 1. Other student should go through the website of Ministry of Health and Population. You should be updated, okay? So that is our intervention. So application of this study to control health problems means to improve your knowledge in terms of your class test. So let me go back once and try to find the response, okay? So second question. Since January 2020 to June 23, the highest number of COVID-19 reported in Nepal. कुन महिनामा सबभन्दा बढी रिपोर्ट भयो भनेर भन्दाखेरि चाहिँ You can find June, definitely June, okay, highest number of the cases. So 77.6% student rightly answered, and remaining, you need to improve yourself, okay? You can see, because you are not up to date with current context of COVID-19. Okay, so this is distribution according to time, according to month. Month means time. Another one is distribution according to which district had highest number of COVID-19 cases in Nepal. Oh, sorry, I forgot to put options here. Okay, so which district? So if we have options, we can find different district here. Okay, and this is distribution according to place. This is time, this is place, and third one is person. Sex means male or female. This is person variable. Okay, so you said 93.1% male and 6.9% female. Actually, majority are male and minority is female. I don't know actual percentage. We should know. Okay, we should Google it and we can find. Okay, so you can see this is frequency. This is distribution according to time, place, and person. That, I think this is all about today's class. And if I try to find the relationship between, okay, a student who failed to respond correct answer in this question and in this question, question number 1 and 2. So maybe same student in both questions, or maybe different student. If I try to find the relationship between, okay, these two questions, then for that we need to go for determinants or analytical epidemiology or analysis. We need to go for further analysis. So this is the reflection of today's class: frequency, distribution, and determinants. Okay, so let me go back again. Okay, now you can see disease frequency. Now you understood very well, I hope so. Okay, inherent in the definition of epidemiology is the measurement of frequency of disease. If you are considering disease, if you are considering any disability like hearing problem or any death, then frequency. Frequency of death due to COVID-19. And summarizing this information in the form of rate, ratio, proportion, or percentage. Okay, prevalence rate, incidence rate, death rate. So this is disease frequency. You already answered in your question number 1. And thus the basic measure of disease frequency is rate or ratio. The second part is distribution of disease. Okay, so it is well known that disease, for that matter, health is not uniformly distributed in human population. Okay, COVID-19 is not uniformly distributed within human population, within population of Nepal. The basic tenet of epidemiology is that the distribution of disease occurs in pattern in a community. So we have highest number of cases in other provinces. It's actually lowest number of the cases in province number 1. Okay, pattern is different. Maybe the people's the age group of people suffering from COVID-19 is different in different provinces of Nepal. So pattern of in a community, and that pattern may lead to generation of hypothesis about contributing factor. So what are the why male cases or male COVID-19 cases is more in Nepal than the most important part is why male are more in our context? Because almost all are foreign employees returned from abroad. Okay, so the male population is more in our country. So we can find which generates hypothesis, and this is actually the answer or the factors responsible for more male COVID-19 cases than female. An important function of epidemiology is to study this distribution pattern in the various subgroups of population by time, place, and person. Okay, time, place, and person distribution. The epidemiologists, what they do, they examine whether there has been increase or decrease of disease over time. In which month there is more number of cases. Is it in increasing trend or is it in decreasing trend? Whether there is higher concentration of disease in one geographical area or in any province than other. Whether the disease occurs more in man than female or in a particular age group. COVID is more, fatal in the elderly age group than child or pediatric age group. Whether most characteristic of behavior of those affected are different from those not affected. Maybe the affected has more prevalence of smoking or air pollution. Okay. Epidemiology addresses itself to a study of these variations or the pattern, time, place, and person distribution, and which may suggest or lead to measure to control and prevent the disease. So that if the COVID-19 fatality is more in elderly group, then we need to be more concerned for elderly population. This is how we can apply the concept of epidemiology to prevent and control any disease. So an important outcome of this study is the formulation of etiological hypothesis. What is the relationship between more COVID-19 prevalence in more in male than female in context of Nepal? So we try to analyze the data. That is called analytical epidemiology, which is actually determinants. It is not. It is beyond the objective of today's class. So to identify time, place, and person distribution, it's called descriptive epidemiology. Descriptive means time, place, and person distribution with frequency. If you try to find the cause, if you try to find the factors or determinants, then it's an analytical epidemiology. Okay. Now distribution by time, place, and person. This is called descriptive epidemiology. It provides comprehensive description by showing its trend over time. Geographical context means place, which district, which time, which month, and which person, male or female, affected by COVID-19. Actually, this is the summary of today's class. Okay, so you can see time distribution. You can see it's a 0 hour, it's a minus. Okay, 11, 10, 9. It's a number of cases. So you have dinner in your canteen or somewhere else in a restaurant. Okay, all students have party. Okay, and they ate dinner. And what happened? After 3 hours, one of the active student of 6th batch and started having diarrhea, vomiting, or shows the sign of food poisoning. Okay, then it increases till 6 a.m. morning. Okay, and it slowly decreases from 7. Okay, it drastically decreases till 8, and at 9 p.m. it stopped completely. So you can see there is one pattern. So few cases, increased number of cases between 5 to 6 p.m. Then almost 50%, almost 60% decrease in the 7 a.m. time, and around only 10% in 8 a.m. and by 9 a.m. there is no cases of food poisoning. So this is typical time distribution of food poisoning. Okay, it happens in many colleges. Okay, so by plotting the time of onset of food poisoning, we can identify what is the cause of this food poisoning among students or among employees. Okay? And you can see, if we draw the line diagram, you can find this type of line diagram. Exposure, and it goes at peak, then it again falls down, and this is called epidemic curve. So it is commonly asked question in your Viva or in your reporting, so in your MCQ too. Okay, it's important. Actually, it's important. Okay, for trace any time distribution of communicable disease, especially infectious disease. Okay. So, what is the median incubation period? Actually, this is beyond the scope of this class, but I'll try my best to give you some concept. You can see this is probable exposure period of food. Okay, someone started to consuming food at 4:30, and someone started at 6 because she came late in the party and completed her meal around dinner around 7 p.m. So this is from 4:30 to 7. So this is probable exposure period of, in case of food poisoning. And after this gap of 1, 2, 3, 4 hours, people started having some problem of food poisoning, and it increases. Okay, at 16 time. Okay, you can see it's a time 16 minutes, or you can say 16 unit of time. Actually, in the epidemiology, it's called unit of time. Okay, so it's peak, and again it dropped down. So after 20 hours, it's stopped completely. Okay, so you can see, you can correlate this bar diagram with this epidemic curve too. Okay, almost similar. And if you calculate from, okay, this time end of exposure to start of sign and symptom, then it is called minimum incubation period. Actually, if you go through any disease, you can find incubation period in range. Okay, not the exact number, right? 6 to 9 days. Okay, the 6 means minimum incubation period, 9 means maximum incubation period, and if you have midpoint, major value of those 2 points duration, then it's called median incubation period. So how to identify from this graph? So let me see. This is at the end of probable exposure period to first onset of poisoning symptom. This is called minimum incubation period. So the first point of probable exposure to last point of sign and symptoms or any presenting illnesses, then it is called maximum incubation period. So if you measure from midpoint of probable exposure period from here to midpoint of this sign and symptom or highest number of the cases, if we join from here to here, okay, midpoint of probable exposure period and midpoint of highest number of the cases in this epidemic curve, so you can find median incubation period. So this is median incubation period. So what is the maximum incubation period here? 20, and it's around 15 hour. 15 hour. And what is the minimum? It's around 1, 2, 3, 4. So 4 to 15 hour means the first case notified in our health institution after 4 hours of food intake and till 15 hours of food intake. So the range of food poisoning, the incubation period of food poisoning is 4 to 15 hours. Actually, it's interesting to know epidemiology curve. Okay, hope you understood. If not, then try to ask me anytime. I'll try my best to teach you. Okay. Another one is place distribution. So during in your senior batch, not you. Okay. So in our field program, we used to have this type of mapping. Okay, house mapping, and this is called place distribution or spot mapping. Okay, you can find these are the spots. These are the different households. Okay. The spatial relationship of cases are shown based on the spot map. A spot map showing the location of case can give an idea of the source of infection, like map so that the cases occur in proximity to the body of water or sewage treatment plant or its outflow. So let me give you one example. Okay, you can see John Snow cholera. I hope you know very well. Okay, John Snow cholera. This is spot map of Golden Square district of London. At that time, there was cholera outbreak. Actually, at that time, they don't know. They didn't know what is the positive agent for cholera. Okay, it's not, the microbiology is not more developed till that time. But just by plotting the spot map, by just plotting the spot map, this guy John Snow found the possible source of infection or contamination. Snow later used a spot map to illustrate how cases of cholera were centered around the pump. This pump, 1, 2, 3. You can see one pump here, okay, drinking water pump, one pump here in the London, okay, at that time. Second pump, third pump, fourth pump, fifth pump, okay. And you can see these dots are number of cases. And you can find more cases in the surrounding area, pump 1, then pump this pump or pump C or this pump, okay. So what it reflects or illustrates that more cases of cholera is due to consumption of water from this pump. So just by going through spot map, we can identify the source. You can see he also made a solid use of statistics to illustrate the connection between the quality of source of water and cholera cases. He showed that companies taking water from sewage polluted section of Thames River delivered water to homes with an increased incidence of cholera. Snow study was the major event in history of public health and can be regarded as founding event of science of epidemiology. Sanitary awakening, itself called sanitary awakening. So just by spot map, he identify the source of water pump is cholera came. Source of water pump is this particular pump, okay, is the source of cholera. So he identified. Till that time, we didn't have concept of microbiology, okay. So just by spot map, we can identify the cause or distribution of any disease or health events, okay. Now person distribution of cases according to age, sex, male and female, you already respond, ethnicity, religion, or exposure characteristic like occupation or use of any food, any drug. So we can have different personal characteristic. Based on that, we can find the person distribution. So we can count the cases is for age and sex. We can obtain census denominator for each age and sex. So how many female, how many male, and we need to identify the denominator. And so in the public health, in the community health, the denominator is more important than numerator. Numerator means the disease person or the cases of disease, especially the clinical practice. Individual case means numerator. If you find the population at risk or the population, then it's called denominator. Okay. So among females, how many suffered from COVID-19? So we can find, we can compare, and we can calculate attack rate and case fatality rate. So attack rate means number of ill people with exposure by total number of people with exposure. So total number of people with exposure, total number of people with COVID-19 exposure, and number of people showing sign and symptom of COVID-19. So we can find attack rate. Okay. Or case fatality rate means total number of the death due to particular disease by total number of cases due to same disease into 100. Then it is called case fatality rate. It's called killing power of disease. It's called fatality, but it also reflects the virulence of the disease. So killing power of the disease or fatality of the disease. So what is the fatality of disease? COVID-19 is around 2%. Okay, fatality. So now, again, you can see this figure, and this is course of typical propagated epidemic. So our current COVID-19 outbreak is typical propagated epidemic. Now you can say COVID-19 is typical propagated epidemic. So what are the determinants of the disease? What are the factors responsible for COVID-19? So these are the determinants. What are the factors responsible for dengue outbreak? Bite of mosquito, okay, collection of water. If you have stagnant collection of water in your surrounding home environment, and which is the favorable place for Aedes mosquito breeding and which spreads dengue. So if your house, if you are suffering from dengue, and you may have possibility of water collection in your surrounding area or within your house. So you can identify what is the factor responsible for dengue in your home than others or other households or family. So now we can figure out the concept of epidemiological triad in terms of time, place, and person distribution. And so based on knowledge of time, place, and person distribution of any disease or health events, we have to fix the equilibrium between agent, host, and environment. There is disruption of equilibrium between agent, host, and environment in the current context of COVID-19. So we all are trying to fixing this disruption on equilibrium between environment or agent and host. When we're able to fix agent or environment, and we'll control or we'll get rid of COVID-19, because the most favorable is environment. Okay, so host, we don't know about host in the current context of COVID. Agent, we already know it's a coronavirus. Only one part is environment. So we need to follow sanitation practice. We need to wash our hand. We need to use masks. We need to maintain social distancing. This comes to environment. So maybe I will ask you questions, more applicable questions, okay, not like theoretical questions, more applicable questions so that you can answer in the context of COVID-19. So let me stop today's class. Kindly go to your Google Classroom and write a reflection within 15 minutes, means before 8 p.m. today, okay? So I'll update questions in your Google platform, Google Classroom platform. Please try to complete before 8 p.m. today, okay? You need to answer. Otherwise, you'll have late submission, and it's not good, okay? To be a late comers or late responders. So thank you very much. If you have any question, any queries, you can ask me through your Google Classroom or your Messenger group or phone call. If you are interested to know more about infectious disease, epidemiology, you need to search, you need to read again and again, you need to ask with your faculties, friends, and seniors. So thank you very much. Have a good day.
Thank you, sir.
So if you have any question, you can ask now, or first try to read, try to find, try to develop the concept of infectious epidemiology. Then you can ask. Okay, the class recording will be available in your in my page. I will share in your messenger immediately within 15 minutes. So you can access class recording from your groups, and you can find this slide in your Google Classroom. Okay, Community Medicine Online Classroom. So thank you very much. So let me stop here.